Now I am going to discuss about first order recurrence relation. Consider a equation an is equal to c an minus 1 plus f of n. So this is first order recurrence relation, and important thing is it is n greater than or equal to 1, where c is a constant and it is known constant, and f of n is known function. Okay, now when we call it as homogeneous and non-homogeneous, let us see. In this equation, if f of n is equal to 0, then we call that recurrence relation as homogeneous recurrence relation. Otherwise, it will be a non-homogeneous recurrence relation. So remember that an is equal to c into an minus 1 plus f of n is a recurrence relation, first order recurrence relation. And if f of n is equal to 0, then it will be a homogeneous recurrence relation. Now we can rewrite this equation 1 as a n plus 1. Instead of n, we are writing n plus 1 is equal to c a n. Here n is there, n minus 1. So previous term. Here a n plus 1, previous term will be a n. So that's what here, a n. C into a n plus f of n plus n. Okay. But one thing to observe is here it is greater than or equal to 0. N will be greater than or equal to 0. But in case of first equation, it was greater than or equal to 1. Because we have started here from n plus 1. For a n plus 1, it will be, n will be greater than or equal to 0. For a n, n will be greater than or equal to 1. So a should start from 1, a1, a2 and so on. Okay, you can remember in that way. Well, now if we put n is equal to 0 in this equation, second equation, then it will be a1, because you are putting n is equal to 0, it will be a1 is equal to c, again a instead of n you are writing 0, so a naught plus f of 1. Similarly, if you put n is equal to 1 in that equation, it will be a2, because n plus 1, n is 1, 1 plus 1 is 2, therefore a2 is equal to c into a1 plus f of 2. Now we can replace this a1. Already we have got value of a1 in previous step. So instead of a1, see, I can write this c a naught plus f of 1, because earlier we have already done this. So this is replaced here. Now a2 will be c square a naught plus c f of 1 plus f of 2. Then when you put n is equal to 2 in that equation, then it will be our equation number 2, then a3 is equal to c a2 plus f of 3. Now what I am going to do, instead of this a2, I will write this entire thing here, then f of 3 and so on. If you do so, then we will conclude at an is equal to c raised to n a naught plus summation of k is equal to 1 to n c n minus k f of k. Okay. Now in this equation, if f of k or f of n is going to 0, then we will be left with a n plus 1, sorry, not here, a n is equal to, in this equation, if you put f of n is equal to 0, then a n is equal to c into c to the power n into a naught for n greater than or equal to 1. Now there will be some examples. Let us see what kind of examples we can get on this first order recurrence relation. Solve the recurrence relation. The given relation is a n plus 1 is equal to 4 into a n for n greater than or equal to 0. And it is given that a naught is equal to 3. Here we observe that there is no f of n, that is, it is homogeneous function. So we consider this equation number 4. Equation number 4 is an is equal to c raised to n a naught. But given equation is an plus 1 is equal to 4 into an for n greater than or equal to 1. Now what we will do is we will make it as n greater than or equal to 1. So instead of an plus 1, we make it as an is equal to 4 raised to n in this form. Okay, because it is c raised to n. Then a naught. A naught is already given, it is 3. So let us replace it. So an is equal to 4 raised to n into 3. That is an is equal to 3 into 4 raised to n. So this is required solution. Very simple examples will be there on this recurrence relations. Now let us try to solve one more example to understand it more completely. Solve the recurrence relation an is equal to 7 an minus 1 for n greater than or equal to 1, given that a2 is equal to 98. Now what is the general formula for first order recurrence relation? That is an is equal to c raised to n a naught. Okay, but given equation is an is equal to 7 raised to n a naught. I mean, it is in the form of 7 raised to n a naught. Now here a2 is given, means we are going to put n is equal to 2. If I put n is equal to 2, I will get in this equation a2 is equal to 7 raised to, instead of n you put 2, 7 raised to 2 a naught. Now a naught is equal to 98 divided by 49, so a naught will be equal to 2. Now we can put it in this equation. So an is equal to, instead of a naught you put 2, 7 raised to an. So this is the required solution. Thank you.